Now, method of preparing insoluble salt. The technique or method to prepare insoluble salt, which is also known as ionic precipitation. Precipitation in short, you can write PPT. This is acceptable even in exam. If you don't want to write the term precipitate, you can write PPT. They accept this term. Now, what's the meaning of ionic precipitation if you want to prepare insoluble salt? So as we discuss, the salts, some of the salts are soluble and some of the salts are insoluble. So all nitrates are soluble, most sulfate, most carbonate, most chlorides, and most sulfates are soluble except barium. Lead sulfate and calcium sulfate. These are the insoluble sulfates. And most chlorides are also soluble except silver chloride, mercury chloride, and lead chloride. And most carbonates are insoluble except potassium carbonate, sodium carbonate, and ammonium carbonate. So on the left hand side, we have salts which are soluble, dissolve, and on the right hand side, we have salts which are insoluble, which does not dissolve. So the technique which we use is called ionic precipitation. What is the meaning of ionic precipitation? When we mix two salt solution, this reaction produce a solid which is known as PPT or precipitate. And this ionic precipitation means when we mix two soluble salt solution, this reaction produces a solid, and this solid is known as precipitate. So example, if I have sodium chloride, I mix with lead nitrate. So these are the two salts. What will be the results? It's very easy to learn this. This is called a double displacement also. Like what happened, the sodium will take position of a lead and lead will take position of sodium. So what will be the product if I add sodium chloride with lead nitrate? What will be the product? So it will form lead chloride and the second salt will be sodium nitrate. So if we write the state symbols, so we have sodium chloride plus lead nitrate gives, if we have sodium chloride plus lead nitrate, it gives lead chloride plus sodium nitrate. I'll write the equation again to explain the idea. So here we have sodium chloride. It reacted, and this will result in a formation of lead chloride plus sodium nitrate. Now we will write the state symbols. We have a sodium chloride solution because so what will sodium chloride soluble or insoluble? You can use this table. Sodium, most chlorides are soluble. So it will be, if it is soluble, it will be aqueous. So this is aqueous. Lead nitrate. What will be lead nitrate? All nitrates are soluble, so it will be aqueous. I want participation from everyone because your participation during a class show your understanding. Don't bother about right or wrong answer. It's your participation which is important. So sodium chloride reacted with lead nitrate. So sodium chloride is aqueous, lead nitrate aqueous. Lead chloride. So lead chloride is solid because here we'll have insoluble salt, so solid, and this side we have aqueous. Lead nitrate, sodium nitrate, all nitrates are soluble, so aqueous will be there. So this is the state symbols we completed. So we have sodium chloride plus lead nitrate gives lead chloride plus sodium nitrate. So what you can see, this will be a solution. Aqueous means solution. This will be solution. But as a result, what it produces? It produces a solid. So when mixing two solutions, if it result in a formation of a solid, what we call this solid is known as precipitate. And this will, sodium nitrate will still be a solution. So mixing two solutions, if it result in a formation of a solid, this is known as ionic precipitation. So what will happen in this reaction? When we mix two solutions, like example, we have a container. We have two containers, one filled with sodium chloride, another filled with lead nitrate. Both are aqueous. Lead nitrate is aqueous, sodium chloride is also aqueous. So when we mix them together into another container, what we will observe? We'll observe as they mix with each other, it will form a solid. And lead chloride is yellow in color. So what you will observe? You'll observe that the yellow solid or crystals are formed. And what is this yellow crystal? These yellow crystals are actually lead chloride. The solution, this is sodium chloride solution, this one is lead nitrate, and resultant solution will be sodium nitrate. So mixing two solutions, if it result in a formation of a solid, we call that as precipitation or ionic precipitation. How I can obtain this salt, lead chloride? Which technique I should use to obtain this salt? So we can simply use filtration. To obtain the solid. And this salt may contain some impurities, so we can wash with distilled water. And dry with tissue paper, or you can also use a filter paper. So use filtration to obtain the insoluble salt. You can, when you wash with distilled water. Why crystallization cannot be suitable here? Because if you do crystallization, you cannot obtain, we want to obtain insoluble salt. Insoluble salt means a salt which does not dissolve. So lead chloride does not dissolve. If you use crystallization, it means you will obtain sodium nitrate from the solution, because sodium nitrate is a dissolved salt and lead chloride is an insoluble salt. So if you use crystallization, you will not get lead chloride, you will get sodium nitrate. So this is a technique. We mix two salt solutions. After mixing the two salt solution, if a solid is formed, this solid is called precipitate, and this reaction is known as ionic precipitation. If you use distillation, again, if you use distillation, if you remove the water, it means you are left with both salts. Because if I use distillation, the sodium, this is sodium nitrate and lead chloride. So if I remove all of the water, means I'm left with lead chloride and then sodium nitrate. So I will have a mixture of lead nitrate and sodium chloride if I use distillation. So the simple technique to obtain the insoluble solid is by ionic precipitation. Is it clear? So example, here we have sodium iodide with lead nitrate. Yeah, why it is called ionic, I will come to that point also, why this is called ionic precipitation. So this is a demonstration how it is done. Example, you have solution. Here you have sodium iodide. Sodium iodide is aqueous. And you mix with lead nitrate, which is also aqueous. So when you mix them together, it will form lead iodide plus sodium nitrate. I did not balance the equation. I'm just explaining the idea. So lead iodide is solid. So this is a solution of sodium iodide. And we will add now to this solution of sodium iodide, we will add lead nitrate. So the moment when we will add lead nitrate, like this solution is there, you can see here the moment when we add lead nitrate, what we observe this yellow precipitate, yellow solid. What is this yellow solid? This yellow solid is actually lead iodide, or which is PPT, or you can also say precipitate. So you can see a solid is formed, and this solid which is formed is actually lead iodide. Is it clear? The idea that what happened when we mix the two solutions, a solid form, we call that solid as precipitate. Why it is known as ionic precipitation? Because when we write the ionic equation, you will understand why it is known as ionic precipitate. First, take the screenshot of this part. So we have lead chloride formation here. So example, sodium chloride mixed with lead nitrate gives lead chloride plus sodium nitrate. This is aqueous, this one is aqueous, this one was solid, and this is aqueous. If this is a word equation, if I want to write a symbolic equation, so when I write the symbolic equation, sodium chloride, so what will the formula for sodium chloride? Sodium is +1, chlorine is -1, so NaCl will be the formula for sodium chloride. Lead nitrate, actually lead valency is +2, so lead is +2, and nitrate is -1. So when you solve, work out the formula, it will be PbNO3 and a bracket 2. Lead chloride, lead is +2, chlorine is -1, so lead 2 chloride will be PbCl2. Sodium nitrate, it will be NaNO3. This is, we complete the equation, but symbolic equation, when you complete it, is not necessary that it will be balanced as well. So you should balance the equation. Now again, for balancing, what we will do, we will always start with oxygen followed by hydrogen and then the last other elements. How many oxygen atoms are on my left hand side? How many oxygen atoms on the left hand side? So we have 6. So we need 6 oxygen on the right as well. Which number I should put here so that it will make 6? So we'll put 2 here. So oxygen is balanced. Oxygen is balanced. There is no hydrogen. So it means then other element is up to you. If I take 2 sodium here, so I will put 2. So sodium is also balanced. So this equation is balanced in terms of hydrogen, sorry, in terms of oxygen, in terms of sodium, in terms of chlorine, and in terms of lead. Then we write the state symbols as sodium chloride is aqueous, lead nitrate is aqueous, this will be solid, and this will be aqueous. No, this equation cannot have hydrogen because you don't see hydrogen here. So if hydrogen is not there, leave hydrogen, balance oxygen, and then other elements. This is mixing 2 salts when it results in a formation of a solid. It is balanced. You can see here, you have 1 lead on the right hand side, you have 1 lead on the left hand side. You have 2 chloride on the right hand side, you have 2 chlorine on the left hand side. 2 sodium on the right, 2 sodium on the left. So this equation is balanced in terms of all other elements. Now, after writing a balanced symbolic equation, you have to write ionic equation. And how to write an ionic equation? To write an ionic equation, you will write the balanced symbolic equation and so write balanced symbolic equation with state symbol and cancel the common ion in aqueous. So this equation, I'm writing it again. So it was 2NaCl, which is aqueous, reacted with lead nitrate, gives lead 2 chloride plus 2 sodium nitrate molecules are produced. This will be aqueous, this will be aqueous, solid, aqueous. So first I highlight this aqueous substance. Sodium chloride is aqueous, lead nitrate is aqueous, sodium nitrate is also aqueous. Then what I will do, I will cancel the common ion in aqueous. Nitrate ion is there, both aqueous substance, I will cancel out. Sodium ion is there, I will cancel out. So what I'm left with, I'm left with 2 chloride ions and 1 lead ion. So 2 chloride ion, 1 lead ion result in a formation of lead chloride or lead 2 chloride. That's why we call this as ionic precipitation. Why we use the term? In the beginning, I used the term, this is called ionic precipitation. Why ionic precipitation? Because ions react to form a solid. So lead ion is there, chloride ion react to form lead 2 chloride. That's why we call this as ionic precipitation. Is it clear? So this was aqueous, ion was there. This is also aqueous, but it results in a formation of solid. Now, as you can see the equation, if I want to prepare lead 2 chloride, you can see the balance equation. I need 2 molecules of sodium chloride and I need 1 molecule of lead nitrate. So if I have 10 cm cube of lead nitrate, how much sodium chloride is needed for a reaction? Because 2 molecules of sodium chloride reacted with 1 molecule of lead nitrate. So if I have 10 cm cube of lead nitrate, how much sodium chloride is needed? So I need double of that. So it will be 20 cm cube. Same thing, if I have 20 cm cube of lead nitrate, how much sodium chloride is needed? So it will be double of that. So we need 40. Why? Because you can see here the ratio, like 2 molecules of sodium chloride are reacting with 1 molecule of lead nitrate. So if 20 cm cube of lead nitrate, I should have a double volume of sodium chloride for this reaction to occur completely. The ratio of the molecule reaction, that 2 molecules of sodium chloride reacting with 1 molecule of lead nitrate. So ratio is 2:1. So if I have 20 cm cube, I need double of sodium chloride. Now, how we can prepare a salt by this method? Take the screenshot, then I'll explain how you can prepare a salt by this technique. So example, I'm taking the same example as we already wrote the equation. Example, we have sodium chloride was balance equation should be there, reacting with lead nitrate gives lead chloride plus sodium nitrate. So first what you will do, first write the balance symbolic equation. To identify ratio between the reactants. So first thing what we will do, if we want to write this method to prepare a salt, the insoluble salt, we want to prepare this lead to chloride. So first thing what we will do, first write the balance symbolic equation to identify ratio between the reactant. In this one, what is the ratio between the reactant? The ratio between the reactant is 2:1. Means the volume of sodium chloride should be twice as compared to lead nitrate. So what will be the first step? So what will be the first step? Take in this, because specifically this answer may vary according to the salt which you are preparing. So take 20 cm cube of NaCl and mix with how much lead nitrate I should take. If I'm taking 20 cm cube of NaCl, how much lead nitrate should be there? So it should be 10 or half of that. So take 20 cm cube of lead sodium chloride mixed with 10 cm cube of lead nitrate. So as we mix them together, the two salts will mix with each other. So which result in formation of insoluble salt, lead chloride. Then what you will do, you will filter to remove insoluble lead chloride. So filter to remove the lead chloride. When we'll filter to remove lead chloride, this will be a residue for us. Then what we can do, we can wash the residue. Residue is the salt which is left on the filter paper, and then dry with tissue paper, or you can mention filter paper. Is it clear how we prepare this insoluble salt? So we have two solutions, salt solutions, we mix them together. The moment when we mix the two salt solutions with each other, this will result in a formation of a solid, the insoluble salt or solid. And how we can remove this insoluble salt? By filtration. And when we do filtration, we will just wash the residue. Residue means what is left on the filter paper, the insoluble solid, and then dry by using a tissue paper or a filter paper. Some of the salt we can also dry in oven, but why do we need to wash this? Because what happens when you mix them together, when you filter it, so maybe this salt may have some of the solution trace, like you use a conical flask and you filter it. So when you filter, so this salt, the crystals which are left on the filter paper may have some solution on it, like trace of solution on the surface. So, and this solution contained a dissolved salt. So what we want to, we wash with a distilled water or deionized water, so that any impurity, any trace of solution which are there on the crystals will be removed. Otherwise, what happens if from this solution a salt can also form? Is it clear how we prepare an insoluble salt? So only thing which will change is this part. This part depends on the reaction. Like here in this reaction, the ratio was 2:1. That's why I took 20 cm cube of sodium chloride with 10 cm cube of lead nitrate. If another example, I'm giving another example, take the screenshot. So example, you have sodium sulfate reacting with barium nitrate. This will result in a formation of barium sulfate plus sodium nitrate. Most sulfates are soluble except calcium, barium, and lead. All nitrates are soluble. This will be solid and this will be aqueous. But I should write a balance equation. So 3 to 6 oxygen, I will put 2, 6 and 4, 10 oxygen. So it makes 10 oxygen. So this equation is balanced in terms of all other elements. Now you can see in this one, this balance in terms of sodium, barium, sulfur, oxygen. So you can see what is the ratio between them. The ratio between the two salts is 1:1. So in this one, if I'm taking so what will be the step here? If I'm taking 20 cm cube of sodium sulfate, then how much I should take? I should take the equal amount of barium nitrate. 20 cm cube, I should also take 20 cm cube because the ratio is the same. And then the other steps are similar. What are the other steps? You can see we will filter to remove, and here it is the salt which we produce is barium sulfate. And filter to remove insoluble barium sulfate. And then wash the residue with the distilled water and dry with the tissue paper. The second thing, a common question they ask, writing an ionic equation. So if I want to write an ionic equation, I have sodium sulfate, barium nitrate, this will result in a formation of barium sulfate plus sodium nitrate. So we highlight the aqueous substance. So we highlight these aqueous substances. Then we cancel out the common ion. What are the common ions? Here we have sodium ion common, we cancel out. We have nitrate ion common, we cancel out. So what we are left with? We are left with sulfate ion. And we have barium ion. And this result in a formation of barium sulfate. So aqueous and solid. Is it clear? So this is the ionic equation for this reaction. So the question which you will find related to this topic is writing an experiment to prepare the insoluble salt and writing an ionic equation for that reaction. Now I'll share some questions related to these topics, preparing the insoluble salt, practically how you can prepare, and the past paper questions. Less than a minute left, so I'll share another link with you.